Okay, Bismillah ar-Rahman ar-Rahim. Now we have to uh, import the specific coordinates of that location of top left corner. Similarly for the
question تاسو د کوم کاپي کو د فګر دا مو پورا کاپي نه کوته څلور پنځه ډیجټس مو کاپي کنه د دې سره
daji asal ki actually this 43 is s is basically showing the zone of that specific region. So we are just locating or copying the coordinates of that specific region, which is basically this is the x value and this is the y value. So therefore we are just copying these two values. So always remember that the first value is the x and the second value is the y. Okay, is that clear?
Clear.
So now zoom to the top right corner as much you can, and then click on that specific location. So after clicking on it, आवाज दर्जी जी?
Yes, Razi, आवाज.
Okay, सही. I will copy the x coordinate and will put into the top right corner. Okay, then copy the x coordinate, y coordinate, and put into the y top right. Similarly, for the bottom right corner, so this conversion, UTM conversion, you will be using if you have used or you have downloaded your imagery in that specific projected system. If you are downloading in another projected system and using and copying the ATM projected coordinates, then it will not be accurately aligned in that workspace. Bottom right, okay. I will copy. Click on OK. The image will be loaded. So by that imagery, you can use easily the layout tools in order to define the pipe system. Okay. So this is a one way to in order to define a model in a WaterGem. Basically, I want to show you that how to create a shape files in a ArcGIS, and then how to import that shape files like a junctions, point file, and lines in the form of pipes in the form of lines and polygon. So stuff like that are how to create in a ArcGIS, and then how to import that into the WaterGem. Basically, I want to show you that as well. So if you stuck in that in if importing and defining the imagery or the elevation file, so then how to utilize the RGS in order to define the junctions and pipe in a for a water supply network. Okay, so in order to create a point or a junction, first of all you have to create a folder connection, and that folder connection and that specific folder you have to click right on that, click on new and create a shapefile. So these are the different formats file your database. And so basically this is not closely related to GIS, therefore I'm not going in depth in detail. So I just create a shapefile junction, change it to the point. So junctions will be defined as a point. Also define a coordinate system for it. So we have defined a coordinate system for a map 43 north. You can use at that, and you can click on this global icon, and you can define it from here as well. Projected coordinate system, and going from here, scrolling down UTM, and then scrolling down your WGS 1984 Northern Hemisphere, and that find the specific UTM zone 43 WGS 84 1984 UTM zone 43 north. So how to find that 43, and specifically, and we are always lying in the north region of that specific coordinate system. So finding of that 43, 42, and 41 number, so use that coordinate conversion tool. So I will run the command. The feature will be created in that specific region. So how to use that junction shape file? So first of all, by clicking on that junction, going to the edit, click on the create, junctions will be created. So where you want to create the junctions, so you can just click on there, junctions will be created. So I am just doing a randomly. If you want to design a water supply system, then you will have to take care of that. If you want to go out of that command, just click on the save command, yes, edit, and click on the clear command as well. So after that, if you want to define a shape file for a pipeline, so how to define, right click, new shape file, pipe line. So basically we define pipe as a polyline, coordinate system is a current map, UTM zone 43 north. So the pipe will be created. If you want to change the symbology of that pipe or the point, just click on that, double click on that symbology, and you can then change it from here. The symbology will be changed. So by clicking on the pipe shape file, going to the edit, click on create. So after clicking on the create icon, you will have to click on the pipe button as well. So these are the different options in order to create the pipe. So here I want to show you specific to these two. You can check these two as well. It is a very simple. Just go through it. So first of all, I want to create a line feature for using this. So if you are using this feature in order to create a line, so it will snap. So you should enable this option as well in order to snap it easily to that specific point. So it is snapping to the junction point. If you click on that junction point, so after clicking on this junction, you have to click on F2. If you didn't do not click on the F2 button, so it will create the as a whole one pipeline for all the, for example, if you want to click on this, so all of this pipe will be considered as a single pipe. So therefore in in between two junctions, there's always the pipe is separated from the other pipe. So therefore, in order to create a pipe in a GIS, you have to click on F2 after clicking on the right junction. So it will create pipe. So you can see here from attribute table that this pipe have a separate entity. Just right click on the that pipe shape vector file and then click on the attribute table. You will get to the attribute table. After that, click on the junction and then another junction and click on the F2 button. And the easy way to do that is just using this 2-point line command. It will automatically finish the polyline feature after clicking on the second point. So I'm using that as well. Click on the junction, another junction, so it will create it automatically. So don't need to click on F2 if you are using this feature. So sometimes if you are using a pipe, creating a pipe in a curve, then you have to use this function. For example, I'm using this function. So I want to create a pipe in a curve way. Then you have to click like that near to each other, the different nodes near to each other, and then click on junction and F2. So this entity will be counted separately. You can observe that that entity showing the blue is selected in attribute table as well. So always remember, if you are working on this tool, the line feature tool, so you have to select F2 or this click button after connecting to the junction. So I have created a pipe. So I want to calculate the length of each pipe, that how much the length of each pipe is. I have to create a separate table. So in order to create a pipe, a length of each pipe, you have to remove this selection, because if you calculate the length of a pipe, so it will only calculate the length of that pipe specifically to the selected feature. So click on this clear button and go to the right click on the field and then left click on fields. You will get to the that editable attribute table. You will then click on the click here to add a new field. I will name it to the length. then using a double. So these are different format because I'm using here double because there will be some lengths in the decimal number as well. Therefore, I'm using a double. If you are, I'm you if I use the long format, so it will showing in a whole format, not showing the decimal, the numbers in the decimals. Therefore, I'm using the double format in order to get the numbers in decimal format. So click on the numeric, how much decimal you want after point. So I want 3 decimal points. So after, so click on save all changes. Yes, the field will be created. Now, how to calculate the length of each pipe? Just right click on that field, calculate geometry. You want to calculate the length, click on the length property. You can also calculate these different properties. The coordinate system basically is the length unit is the meters. We want the length in meters, and the coordinate system we want to use is that UTM 43 north. So click on OK. So length of each pipe will be calculated automatically. So I want to save this file as well in the GIS folder. So we created the length, the junctions. Okay, I want to show you that how to assign the elevation value to that specific nodes or the junctions. So I have to add the elevation file as well. This is basically the elevation file. This is a raster file, and I want to get the value where that junction lies on that raster to calculate the elevation of that junction. So these are the different junctions. So I want to calculate the elevation of these junctions. So what you have to do, if this geoprocessing is not showing in your RGS workspace, what you have to do, you have to go to the view tab and then click on the geoprocessing icon, and in that you have to type extract values from extract values to point. So you will use, you have to type extract values to point. Click on this command, this tool, and then you want to extract elevations from this raster to the junction. So input point feature will be the junction, the input raster will be the elevation TIF, and output will be the where you have saved your files. So junctions with elevation. Run the model. So it will, so how to show this? Just click on the junctions with elevation, vector file, click on attribute. So this basically raster will use showing the elevation of these specific junctions in a meters, because we are using elevation having a UTM 43 north coordinate system which have a units in a meter. So now we have calculated the length of a pipe junctions. So how to import these? For example, if you want to import these pipes, and junctions in a WaterGem, then how to import these files in a WaterGem. So you will use the model builder. First of all, I want to delete junctions.
شو
जी दिया तौलिया भाई तौलिया भाई ताफ सवे So what you have to do, you have to go to the home tab, then click on the model builder, click on the new, then after clicking on new, you have to select the data source type. So basically the data source type are the Esri shape files. Then you have to browse to the junctions with elevation. You can preview it as well. These are the labels. Click on the next. We are using the coordinate unit of your data source is basically the meter. So how would you like to handle your synchronization between source and destinations? So first of all, I want to add objects to destination if present in source. Prompt before adding objects. So it will go give me a dialog if it's add the object to the workspace of WaterGem. Remove objects from destination if missing from source. So if any point, if the it is not found in the source, so it will remove from that destination or from the WaterGem's workspace if it is not found in that source. So if you want to, for example, if you want to import the junctions or a pipe at second time, for example, if you make any changes in a GIS, if you want to again want to import it a second time or third time, so you will uncheck this point. You have to only check this point if you want to import, if you are importing it at a first time. If you check this point, it will create, if it will make a duality, it will make a duplicate of these junctions or a pipe in the WaterGem workspace. So you have to uncheck in this feature if you want to import point or the junctions or a pipe at a second time or a third time from these GIS. So this is our first time, so I'm using this point, and you will use this feature update existing object in destination if present in source. Create a reference object automatically. For example, if you have created a valve or a pump in a GIS, so to create a valve or a pump, similar method like for example for a we have used for a junction. So you have create a separate file for a valve and separate file for a pump, and then create using these specific files the pump and the valve will be create these specific objects in a GIS. Click on the next. I want to map elements by a key field, so I'm using a label field. Here I want to show you that this field is using as a for a mapping, and I'm adding it to the current scenario, and you can also add it to the new child scenario as well. For example, if you have not snapped properly your pipe element to the junction, so you can also check this point. So a tolerance 100 meter means that any point or junctions, if near to the, for example, there's a very high value in 3 meter of vicinity of that pipe, so it will automatically connected, that pipe will automatically connected to the that junction. So we have already snapped to that specific junctions, so no need to use this. Click on next. So here what you have to do, you have to design the property of that elevation. For example, hey, the raster values are basically the elevation of a junction. So what you have to do, you have to go to the property. The key field is basically the label property, and we are basically using the elevation. So the raster field in a junction file basically contains the elevation property having a unit of meter. Going a next. Would you like to build a model now? Yes. And if you are importing it a second time, so use a no. Click on yes. So it will automatically. So you can see that the points have been created in a WaterGem as well. So now I will import a pipe. So you can see here that the elevation point which we have used, you have assigned in a GIS is automatically updated as well here by assigning the property of elevation to that specific raster value attribute. So the elevation for each junctions have been assigned. So how to import the pipe? I will create another scenario. Easy shape files, select a data source, pipe. You can preview meter. So length property, you have to assign the length property. So key field, make it the key field as to the labels. Keep it as it is, and then click next. Yes, entire model. Yes. So missing topology. Edit. Next. If you have to connect your pipe to that specific nodes, then you have to click this point as well. Establish connectivity using spatial data using a toll sum of 1 meter. Seven pipes created. So you can see here that the pipes have been created with a curve as well. So here you can observe that the length have been assigned. So basically, I think that I want to show you something. Pipe table. Right. Okay, so the workspace has been scared, so no need to worry about the length. Basically, if you import from GIS, so sometimes it happens that the map is not scaled according to the workspace. So what you have to do, you have to go to the flex table if you after importing a pipe to the workspace, and then you have to check that the has user defined length, and then based on that you will basically this feature will be you will assign in the importing from the here. Okay, I want to show you here. Let me show you here. If that property is this property is not working, then you can assign it from here. You will use this property. So after using this property and then going to the pipe table, what you will do, you will just click here's your define property global edit, and then you will check this point, this icon, and all the properties will be updated here automatically. So this is how to import the data from the GIS into the WaterGem. Other thing I want to show you that in a GIS, for example, uh, you have, for example, you have point data like want to show you where I have created. I think I think this is point data. So I manually created by myself. So basically, this is the XY coordinate and the Z value of this specific surface. For example, you consider it is a these points have been got it from the topographic surveys, topographic survey, and you want to create a surface from this Excel data. And how to create it? So I want to show you that as well. So what you have to do, you have to go to the view processing tool, and in that you have to type XY table to point, XY table to point. So where is the table? Click on this folder button and click on the GIS where you have a specific table. You have to go to say WaterGem. So where the file? Let me do by another. Okay, go to the catalog and make a connection with the WaterGem. So this is basically the point data imported to the workspace. Down right here. So after importing it to the table to the GIS workspace, what you have to do, you have to go to the XY table to point. Okay. So you will click on this point data, the table you have imported, where you have to save this. So basically what it will do, it will convert this specific table into the point shape file, which will be showing as a surface. So the shape file can also be used as a surface in a WaterGem, and how to convert into the DXF format. So the DXF format can also be used in the WaterGem. So I went to surface one. So assign X field to the X coordinate where you have saved the X field or the E string in that specific file. Open the file. So in a X column, the values, the which coordinates you have saved, you have to design as it is in the in this portion. Similarly for the Y field and the Z field as well. And you have to define the coordinate system. So basically, these values are in WGS 1984. You can also convert it into the that specific UTM zone. For example, if you did a survey for Ektabad or Mansehra and for Peshawar as well. So calculate that surface point in a WGS 1984, and you can then project it into the UTM zone as well. So you can change this to the UTM zone 43, 40, 42 knot, 43 knot.